All right, let's go. Hey everyone, I'm Michael, staff engineer at VMware, Office of the CTO. Super happy to be here on the show at VMworld CodeCon. And together with me is Rafa. Rafa, you want to introduce yourself?
Hi everyone, my name is Rafael Brito. I'm 1 year old at VMware, application architect, and I'm here as many of you to learn with Mike how to build the Kubernetes operating Go.
Perfect. Yeah, we're learning all together. So this is a 90-minute session, and since we have 90 minutes, we thought we'd break it up a little bit into a little bit of theory, like a bit of PowerPoint, but hopefully not boring you out because we want to cover some concepts which are required and kind of fundamental in understanding how to build a Kubernetes operator or controller, just to get the basics right. And so we're assuming you're not a Go developer, you're not a Kubernetes developer, you have not yet written an operator. If you have done so, perfect. Like comment, reach out, spot things that might be wrong, or you find something that you want to contribute to the session as well. That's perfectly fine. We have some advanced topics as well. So hopefully if you have some experience, you will get also something out of this. But the main focus here is basically for people who are new to Kubernetes, new to Go, new to building operators. All right, quick disclaimer. I'm sure you've seen them if you have 10 at VMworld. Seen it before. I give it a second to read it, please, and then we'll go. Okay, so our agenda will quickly frame the problem that we're trying to solve here in this kind of hopefully interactive session. Then we discuss and share a little bit of the theory behind Kubernetes, extending Kubernetes, and what operators are, what controllers are, etc. And then obviously most part of this session will be into the code, into the deployment of an AVM operator using the KubeBuilder framework. And we have a lot of resources that you will also get with the slides. I'll share a link to the source code and all the information later throughout the deck. Yeah, so let's go. So what is the goal for this talk? And if you haven't seen the abstract, it's basically in a nutshell what we're trying to achieve. So given a YAML file, and I'm assuming you have seen YAML before, so basically it's a text file if you want. Given that file, we want to create objects in vCenter. We call these objects VM groups. So that is the type that we are going to introduce here as a concept. And a VM group is, we kind of defined it here loosely for this exercise, as a group of virtual machines that are managed together. If you have a little bit of Kubernetes experience, think of it like a replica set where you have kind of a group of pods that are managed together in their lifecycle based on the replica set controller. And as part of this, we also want to add some information, like some declared state or declarative state that a user, developer, operator, whoever wants to use this can define as part of this process of managing this VM group. And so obviously there's a name. In this call, we call this VG, short for VM group, VG-1. So that's going to be the name for the VM group. And then there's a spec. And a spec, you've probably seen this in other Kubernetes talks about like core types there. There's always a spec which declares the desired state that you want to achieve. For example, here we want to have a VM group that has 3 replicas. Think of like virtual machines, each of them having 1 CPU and 1 GB of memory, and based on a template that we here call VM-operator-template. So that is our spec. That is kind of what we want the machinery to do for us and to deploy. And then at the end, we want to get that inside a vCenter environment where we then want to see inside a folder that is called like namespace-name. In this case, the namespace is default, and then the VM group name, which is VG-1. So you see default-VG-1, and then you see 3 virtual machines there, which are running and managed as part of this VM group. So that's our exercise. And obviously, we do want to embed it and manage it with the Kubernetes tooling, in this case, kubectl, for example, so that you get some status of like, is the group running? How is it doing? Anything errored? Or what is the configuration of this group using kubectl? And so what we are gonna basically describe here is you're set out to perform this task of given a YAML file, how do we get to the right side of creating and managing a lifecycle of VM groups?
very quick, Mike and everybody. If you have any questions in the meanwhile, just type it in on chat and I'll pick it up those questions and try to answer over there.
Cool, thanks, Rafa. So quick introduction to Kubernetes operators, controllers. So we are not assuming you have heard about that before. So what is an operator or a Kubernetes custom controller? Sometimes like those words are used interchangeably, which is strictly speaking not correct. So the concept has been introduced in 2016 by CoreOS, where some very smart engineers there thought about, well, you know, we run a couple of Kubernetes clusters environments, and obviously we need etcd, like a database for Kubernetes. And the lifecycle management for these kind of backend services, etcd and Prometheus, is going to do hard at scale by a human. So we want to automate this using Kubernetes. So the idea was born to actually extend Kubernetes beyond the types that Kubernetes knows about, like for example, deployments, etc., to custom types, in this case, an etcd cluster, which Kubernetes by design doesn't know about. And so the idea of an operator or custom controller was born. So an operator is an application-specific controller that extends the Kubernetes API to create, configure, and manage instances of complex applications on behalf of a Kubernetes user. Okay, in a nutshell, it's basically given a custom resource definition. We'll see what that means in a bit, but it's basically a description of how this custom resource is going to be defined. In this case here, that's an etcd server. For us, it's a VM group, plus a custom controller, which is the business logic or the logic that then performs actions based on this definition. That's what we call an operator. Rafa, anything that you want to add to this?
Yeah, very quick. There is the first question. What's the difference between operator and controller? And the way that I help me to understand this, every operator is a controller, but not all controllers are operator. Operator has knowledge about a given application and then takes action. Controllers can operate as a controllers and have other types of controllers embedded on Kubernetes.
Right, that's good. And there's like you will see us creating these VM groups later, and strictly speaking, it's more like a custom controller that we are building. There's not so much around the lifecycle. For example, you could say, oh, I want to do snapshots on this VM group. I want to do backups on this VM group. I want to power cycle them all together. That now would become an operator, a VM group operator. So strictly speaking, what we are discussing here is a custom controller that we are building. But you can extend this based on this. You basically can make it an operator. So what are the tools of the trade to get started? If you've seen a session that I did with Tom Schwaller at VMworld, we did a similar session, but very condensed and not much code that we showed there with the Python framework, which is COPF here on the lower of the slide. So that's a Python framework for building Kubernetes operators. But the typical frameworks and kind of the ones that have like the biggest community and support and feature richness are the ones using Golang. And there's essentially two frameworks right now. They used to kind of compete a little bit, but recently like there has been work to harmonize both of them. One, there's the Red Hat operator framework, which it has an operator SDK for building these kind of operators using their framework. And then there's KubeBuilder, which is part of a Kubernetes special interest group that came out of it. And that is also using Golang and is heavily used across the Kubernetes like users and developers for building operators. Before these kind of frameworks existed, you can see like some of them were like born in 2 years ago. And Kubernetes is much older. Before that, there was a lot of like manual boilerplate code scripts that you had to run. So it's gotten much easier to build operators using these frameworks. Okay, quick introduction to Kubernetes architecture, but we'll focus on the operator or developer persona here, not so much, well, when I say operator, building operator persona. Well, and we have in Kubernetes, we basically have 3 layers. I say we have 3 layers. One is the control plane, the brain of the system, which is the API server, the scheduler, a bunch of controllers, and then obviously etcd as a persistent data store or key value store. Then we have the workers, which are called kubelet, these guest OS agents that then run the workloads, which we call pods in Kubernetes. This is kind of the atomic or smallest unit of an application deployment. And then we have an access layer, which is like kubectl or the UI, SDKs, and the REST API. Technically, they are all using the REST APIs on the covers, but most of you might be familiar with kubectl, or if you have used these SDKs before. But if you want to trim it down, basically Kubernetes can be described as an API server that interacts or that has a bunch of control loops that interact with the API server or through the API server. So note that there's like no crosstalk between these controllers. The kubelet doesn't really talk to the scheduler. They don't know about each other, and we'll discuss this in a bit. But take from this picture, take that Kubernetes is an API server with a bunch of controllers doing their work. If we now zoom in a little bit into the API server, I want to make a distinction here between how these components interact with the API server. And I use two colors here on the REST API endpoint. One is like representing commands and one is representing events. We'll come to the distinction in a bit, but it's not that the API server exposes two REST endpoints. One does this and one does the other one. This is just like purely for making the point here that you should think of two different kind of interactions, ways to interact with the system, one being a command-based and the other one being event-based interaction with the API server. Okay, let's take an example here. And here we are using a core type, which is a replica set in Kubernetes. But this is true for the VM group that we're talking about, deployment, etc. So this is purely a manifest saying, hey, I want two replicas to be created. And so if you fire kubectl up, what under the covers it will do, it will issue an HTTP post request or command against the API server. The API server will do some validation, check whether you have access to do so, and some defaulting, and a lot of other checks that the API server does, and maybe will reject or accept your request. And then you might have, well, for replicas that you definitely will have, a bunch of controllers watching for this type. And when I say watching, it's basically they are registering interest in seeing any state changes for that particular object. And you could think of an event that is then fired when a replica set is going to be created, deleted, or updated. So under the covers, we have this kind of duality between commands and events here. So what are commands and events? Commands, and I want to make this distinction here because also architecturally and when you write these controllers, it's good to understand the difference here. Commands are request or intent to do something, and so that means that they can be rejected. And the simplest example is the Kubernetes API server is not there and you fire kubectl up, well, then basically it won't be rejected, won't even reach the API server. So commands are not guaranteed to succeed. That is very important to keep in mind. So you always have to think about retries and these kind of failure scenarios. They also usually lead to higher coupling between sender and owner, depending on the architecture that you're using. But especially for HTTP-based communication, you usually have a REST client and a REST endpoint, like a REST server. And then there's pretty strong coupling between these two components. So if the REST server is not there, well, you can't perform a task, for example. And speaking of REST, that's usually a synchronous one-to-one communication matter where you as a client talk to an API endpoint, and then you exchange some requests, and then you're done. You basically talk to one system, one remote system. On the other hand, we have events, and events are facts, things that have happened. So that's why they also named in the past tense, like created, updated, deleted. That's how you usually can spot these events in a system. And so they cannot semantically be rejected by a receiver. What I mean by that is, yes, you can just ignore these events, but strictly speaking, they have happened. They are kind of recorded and persisted in time. And so things have happened, and this is a fact that cannot be retracted. Also, events, by their nature, they lead to a low coupling between the sender and the receiver or the owner of that event or a logic that you're implementing. So for example, if I'm sending out an event that a pod has been created, for example, I'm not expecting everyone to agree that, hey, yes, I got this event. So you usually use them in asynchronous communication where you broadcast out this information without waiting for a response, which enables a very low coupling between those components and more like a reactive interaction. So now back to Kubernetes, let's see how this choreography works under the covers, because if you're new to Kubernetes, you might assume that the controller manager or like the Kubernetes control plane where like these components like scheduler, etc., are located, that they might orchestrate things for you. But this is not true because of these kind of watch or event-based semantics that these controllers implement under the covers. So here we have our replica set again. We issue a command to create this replica set. And then behind the scenes, the API server issues a replica set created event, which gets picked up by a controller, in this case, the replica set controller. Now, the replica set controller does a bit of logic internally. We'll cover this in a bit, but eventually it will issue a command back to the API server and say, create a bunch of pods or create one pod, depending on the number of replicas that you specified. Then that event or that command is translated by the API server into another event, which is a pod create event, which is picked up by the scheduler. So the scheduler doesn't actually know about the replica set controller or any other controller. It purely listens for these events, does some logic, and then it binds a pod to a node to or basically say, I want this pod to be running on node X. And then the kubelet, the node kicks in, and it listens for any of these bound events, which are like scoped to its own name. For example, here the kubelet X would pick up that pod bound event and would then start the pod, create the container locally, and then send back a command to the API server saying, hey, this pod is now in running state. And the story goes on. This is how Kubernetes basically is implemented under the covers with these autonomous controllers that perform some logic and then interact through the API server with commands and then events. So that's why we talk about choreography and not orchestration in Kubernetes, even though it's called a container orchestrator. And so now inside these controllers, like the replica set controller, for example, what happens there? And this is kind of a closed loop, if you will, that happens there. And it's pretty simple, but also like that's why it's very robust and proven approach of building these kind of highly resilient and scalable systems. So here we have the replica set controller again, just mimicking the logic a little bit here. It gets this event of a new replica set being created. And then it observes, so basically it looks into that event and sees, oh, okay, there's a spec that says I need to run 2 replicas for a replica set here. The name we omitted for brevity, but there would also be a name here. Then it analyzes the current state versus the desired state, meaning how many pods do I have running for this replica set, if any? And then it decides what to do. So it compares basically current and desired state. And then it says, well, if the number of pods for this replica set are smaller than the currently number of pods, then we need to delete pods. If the number, the diff basically, if the diff is smaller than 0, it's negative, then we delete pods. If the diff is larger, then we need to create pods. That's basically what it does. And then it issues this command. So all these controllers perform the similar logic internally of observing, analyzing, and then acting, performing an action.
Very quick. Yes, you can see that it's observing an object. So the controller has this concept of root object. Usually is one controller per object. So you observe one object, in this case, replica set, and then analyze and act. If this action requires involve other objects, it's fine, but is one controller looking one root object, in this case, replica set.
Yeah, the replica set controller. Speaking of which, that's a nice transition. If you look inside Kubernetes, there's this folder package controller. And inside there, you will find for most of the objects, actual controllers. So for daemon jobs, daemon sets, there's a daemon set controller. For cron jobs, there's a cron job controller, and so on. So everything is kind of modeled around this pattern of given this kind of type, root type, as Rafa explained it. You have usually one controller implementing the logic, owning that object. There's a bit of more reading if you want. We skimmed through this quickly because we want to get to the meat of this talk. But here are 2 links from Joe Beda and myself, where like he describes also again this kind of choreography, and he coined it like jazz improvisation over orchestration. Okay. Lastly, some kind of maybe advice or things that might help writing controllers. So why would you want to write a controller at all? Yes, you do want to extend Kubernetes. You might want to have some system that you want to automate and lifecycle manage. And so Kubernetes gives you a lot of capabilities right out of the box. So for example, in Kubernetes, you get scheduling and supervision, kind of self-healing for your system that you don't have to bake into your own system. So for example, if your container or your controller crashes, then Kubernetes will make sure to restore it. You get configuration and secret management. If you need to inject some data into your controller, you get service discovery, networking, everything is kind of set up for you. So this is pretty rich, and like it covers a lot of the boilerplate that you would have to otherwise care about when writing kind of this automation logic for your specific type and object. But having said that, depending on the complexity of your controller, there might be a steep learning curve involved here. So like setting out and writing a controller, and the one that we do here is kind of a toy exercise example. That's pretty neat, but you will see there are topics that we don't have time to cover, but we'll discuss them, hopefully find time at the end, where things get complicated and complex very quickly. So we see a little bit of like a lot of people directly jumping on building a controller on operator without actually realizing that there's a lot of burden in terms of maintaining this, writing the correct code, etc., associated with that, especially the learning curve of understanding how the system behaves and reacts inside Kubernetes. Brian also coined it that client Go, or kind of KubeBuilder, if you will, the de facto SDK is not for mere models. Well, KubeBuilder, he was referring to client Go, which is low level implementation, meaning that there's a lot of things that are very raw or low level, if you will, inside that SDK, which especially for newcomers or non-programmers are really hard to grasp right from the beginning. But work has been improving since then, so that comment is a little bit older from him. So probably is not correct here anymore for me stating that from him. Hopefully that's okay, Brian. And then in Kubernetes, since we have these kind of asynchronous, non-coordinated control loops or controllers that work inside the system kind of almost autonomously, there are a lot of things that you have to be aware of around concurrency and asynchrony in that system. And here's a good article that describes a little bit more about these kind of concepts. So what is the required mindset to write an operator or controller in general? So again, think of these controllers as autonomous processes where you care about a certain type of object that you want to own, manage, and lifecycle. And so almost like in the Unix world where we have these kind of tools or command line tools that we pipe together, but they don't know about each other about. So this is the single responsible principle that you should aim for here when writing a controller, and not writing an Uber controller that does everything. Again, this decoupling via event-driven messaging, especially if you come out of the world where you usually interact with systems using REST or synchronous communication, this reactive approach and asynchronous way of dealing with the system state might be new to you. And so it also means that you have to be aware of things that you have to program in your logic. For example, concurrency and asynchrony, that means it takes time for this information to trickle through Kubernetes. So you've seen the example before where we had the replica set controller, the scheduler, and then the kubelet. It's not like this, things don't happen instantaneously inside the system. For example, a kubelet could be down. So even though the replica set created a pod and that pod got be scheduled by the scheduler on a node, if the node is down, well then things won't happen there. Like if there's no node, things won't run. And that's this kind of eventual consistency inside the whole model there, which is very robust in terms of the scalability and robustness the system brings. But it also means you have to think a little bit more around dealing with consistency in the state. Also, don't rely and assume any order in the system, meaning that if you have multiple controllers performing some actions, there's no like, oh, this is going to happen first and that's going to happen later. So this order, if at all, can only be guaranteed within your own business logic and your controller code. Stateless over stateful, meaning since API server backed by etcd has or it should be seen as the source of truth if you're interacting inside Kubernetes, make your controllers stateless by caching important information in memory, and KubeBuilder and Client Go give you a lot of tools for that, where you just keep the required information in memory, and you don't have to snapshot or store it locally or checkpoint locally on a file system, because when you crash and you come back up, you just replay or reread that state from the system, and then you continue from there. So this makes it a little bit easier because you don't have to deal with local state, but it also means that you have to be aware of this eventing semantics under the covers. Think about defensive programming, like things will go wrong, obviously, and crash. So always be prepared to crash right away. There's no kind of atomacy or consistency boundary around any action that you perform there. Like, for example, if you create a service and then a replica set controller, those things don't those things don't happen atomically, meaning the service might be created and then you crash, so the replica set didn't get created, for example. So you have to be aware of this. And then also anticipate the effects on the rest of the system when you perform an action. For example, if you write a controller that wants to spin out 100 pods, is it wise to just say like create 100 pods, or should you better like stage them in like batches and slowly progress them through the system? Those are some things that you have to be aware of, or should at least consider when writing your system. And then, and this is also part of our exercise here with the side effects, since we are interacting with Kubernetes and vCenter, the guarantees that the Kubernetes and KubeBuilder and the platform give you might not hold true for the systems that you interact with, like, for example, vCenter. In vCenter, we don't really have like this kind of event stream that we can attach to and feed our system. So be aware of anything that goes out of Kubernetes. You kind of have to deal with different semantics there in the system. And we'll cover this also as part of the controller exercise. Okay,
Mike,
so,
very quick. One aspect that it's a myth that I learned that is not true when you build a controller, and that you need to be super user of the cluster. No, you don't. You can build a controller and you create a specific RBAC role just for your controller. So if you're a user of a cluster, you can talk to your admin. The extension of creating CRDs, you need the admin privileges, but after that, you can just have one single role just to have your controller running.
Yeah,
so that's a great feature.
And that's pretty nice what the Kubernetes API server gives you basically for the types that you define and for the controller that you write. There's KubeBuilder gives you a lot of bootstrapping or scaffolding that makes these role-based access controls and the type definitions way easier than it was before. Okay, so last slide before we go into the code. And this is just an overview of the model that we are basically building. So on the right, we have Kubernetes, we have the API server. We're going to create custom resources, which are our VM groups, here VG-1, VG-2, just as an example. Then our operator or custom controller will list and watch against the API server for these kind of changes when these objects get created, updated, or deleted. And then it will issue vCenter commands through the vCenter API that create, clone, or destroy folders and or virtual machines based on a template. And so for VG-1, you will see a folder VG-1 prefixed by the namespace that this object was created in, running on ASICs or on a vCenter DRS cluster. Okie dokie. So this is the code here. You will get the link later. The slides are there, code is there, and an awesome description that Rafael wrote on like a step-by-step guide to get you from 0 to this running controller in your own environment. Because in the interest of time, we will skip certain code pieces. They are important, but they are not super important. So we'll just kind of refer to the code, to the source code later, but we'll cover the most important pieces for writing the controller.
Just quick, if you have any questions, just type it in. I'm gonna put on the chat the GitHub. There's a step-by-step, everything that Mike gonna show, it's in there. You can replicate at your own leisure.
Exactly, cool. So what I'm gonna do and use is I'm using Kind, which is Kubernetes and Docker, to run a Kubernetes cluster locally on my MacBook here. So kind of super neat if you haven't heard about it. It's amazing to like, even if you just want to learn Kubernetes, you get a Kubernetes cluster locally on your machine. So that's what I'm using. And here is the code base. Connect-VM operator, and Rafa did an amazing job. Like you can already tell from the table of content, there's a lot of things that he's covering there where we will skim over a little bit due to time constraints here. But basically he gets you from 0 to running controller. All right, so what is the first thing that we have to do? Well, we have to install some software. We already mentioned Kind or any Kubernetes environment, so you can interact with the system. Obviously Git to clone the code, get the code. We use Go, obviously. So that I have installed, I have Docker installed if you want to build the images locally. So you can run the controller that we will show in a developer mode, meaning you don't have to build any controller, you don't have to build any container image, you don't have to ship it to a Kubernetes environment. You can actually run it locally and interact with Kubernetes. So Docker is not strictly needed, but recommended. We will use KubeBuilder as the SDK for bootstrapping our logic, our controller. Customize is also used internally to build out these YAML files that we then use to create objects and run the controller. And then, yeah, an IDE and the Docker Hub repo. Okay, so you need a Kubernetes cluster. I already have that, so I can skip this, this piece here. And then you need a vCenter environment. Let me show you my environment. This is a nested environment. So we have a bunch of nested ASICs virtual machines here. ignore that test VM for now, focus on the folder. So what we decided to do, just to like clean this up a little bit, is to have a folder which will be owned and managed by our operator, which we call VM-operator. Under this folder, then our groups will be created. So you will see subfolders in there. And then there's also the template in here, VM-operator-template, which we'll use for cloning. One thing that I forgot to mention is right over here. Again, we are building an educational toy, quote, quote, VM operator, purely for showcasing like what you can do with it, with Kubernetes. But of course, this is purely for education purposes, meaning for production grade environments, etc. You will definitely not use this, but we recommend to look at the cluster API provider vSphere, which a great community is working on to basically achieve the same, but in a more robust and production grade way. The reason why we picked to build like our own project here is to, first of all, explain you the tools to be used, but then second, to have an easy code base to understand, because the cluster API code base is larger, and especially if you're new to Kubernetes and this topic, it would be probably a bit too overwhelming. But feel free to dive into this code base because it's the actual, the correct code base for production environments. Okay, so we have vCenter. I showed vCenter. And then you would clone the code because the tutorial here assumes that you would follow along the code where you can just copy over into your own folder the code that we have written. And so you can explore the code and then gradually build out this controller by following along this tutorial here. Before we jump into building that out, I want to actually show you that thing in action, the controller. So here's my terminal. Hopefully everyone can read my screen. So it's kind of split screen. On the left, this is my Kubernetes kubectl here, alias 2k, to save some typing, where I'll fire up the commands. Here on the upper right, we see all the VGs, all the VM groups that are currently installed in the cluster. We don't have any because we're going to create that. And here on the right, lower right, you see the controller. So we already have a running controller in the system just to show you like how it's interacting, and then we'll go back off building out the thing. If you want to check for like these kind of VM groups or custom resources, there's a nice tool or command in Kubernetes kubectl API-resources, which will list you all the API resources that Kubernetes knows about and understands. And in our case, we want to get to our API group, which is the vm.codeconnect.vmworld.com API group. So we usually use these domain names to build out this API path. And then we have custom kinds or objects like VM groups underneath this API group. So since we already installed and set everything up here, like the custom resource definition, everything is already loaded in Kubernetes. Kubernetes tells us, yes, I know about VM groups in the API group vm.something. It's namespaced, meaning we can create objects that are in namespaces, in Kubernetes namespaces, and the kind is called VM group. And we have a short name VG. So let's create a VG, a VM group, just to see the thing in action. So you actually believe that we did something here. So here's VG1. And this is the YAML file you saw earlier. In fact, let me try something. Yeah, okay. So since Kubernetes knows about the schema, which is the custom resource definition, I'll show you later. It knows and understands what are required fields, what can I type into here into this field. So for example, here it tells me, hey, you have entered an incorrect type for replicas, basically nothing. So I need to put something in. So we'll make it 3. For CPUs, let's try 20. Oh, that's not allowed. Why isn't it allowed? Okay, we put a maximum on there. And we'll show you how you can do that to enforce like certain validation already before this YAML file hits your cluster. Okay, let's go back here, make it this default, and then let's create this, I think I have an operator namespace, this object, just so you see it. Oh yeah, I have a VM operator namespace, and then we do create file, and then I think is it here, VG1 samples, so the one that you just saw. And then here on the lower right, you see the controller kicking in. It does some magic. And then here you also see already an error popping up. That's interesting. Obviously, demo will check that in a bit. But you can actually see that the operator is doing performance something, and it will tell you what it did or what it tried to do. In this case, it errored out by saying VM operator template could not create VM group in vCenter, could not get VM operator folder, VM operator not found. That folder is not found. Okay, let's see what it did. Let's go back here to my vCenter. Should have not done anything. Okay, so now we're into debugging mode. And let's see what it told us. Could not create VM group, could not create folder, not found, folder, not found. This is weird, that folder is there. VM operator. Let me do something and run this guy locally. Maybe this has the wrong vCenter. So let's quickly delete the operator, delete deployment, could connect operator. So this will go away here. And then export some variables. This should be my host. So I'm now going to run it locally, the operator locally, VM-operator, VM operator template. That is also correct. Okay, and let's run the manager locally and see what it does. Yep, this looks better. So maybe that was because the operator that was running was connected to a wrong vCenter. We did some testing before. Okay, so let's jump back into vCenter. And it was actually too quick. But what you see now here in VM-operator, our controller created a new folder called VM-operator-vg1, like the namespace and the object name of the object. And inside that folder, it created 3 virtual machines as part of the spec that we wanted. And just to check whether the hardware is correct that we specified, I think we did 1 CPU and 2 gigs of RAM, Rafa? I forgot. Oh, 1 gig of RAM. Okay, 1 CPU, 1 gig of RAM.
1 and 1.
Exactly. All 3 are running. And our controller basically said that the replica count is in sync. And then that's it. So it's done. Successfully reconciled. The VM group is running. Okay, perfect. So let's now dive into the code of what happened actually under the covers. But before that, since we have some running code here, you are actually more interested in, okay, so how do I get to this kind of whole code base here? And in order to bootstrap such a controller, we are using KubeBuilder. So KubeBuilder, let's go back to the manual. Where is it? Here. KubeBuilder is, again, this SDK for creating these controllers, and it does a lot of stuff for you right away. So you definitely want to use something like KubeBuilder. Okay, let's follow the tutorial along. We'll create a folder just to where our code will reside. Okay, I did that. And then we need to initialize the directory with the Go modules path. Go modules is basically dependency management for Go. So Go knows which kind of path it needs or namespace it needs to take for importing all the dependencies. So trust me on this one here. And then the next step is to create our API groups, version, kind, etc. And here's where KubeBuilder kicks in. So there's a command KubeBuilder init, which basically initializes a new project. And then you give it a domain. The domain in this case is codeconnect.vmworld.com. That's kind of our overall domain. The reason for that is that you might want to have different groups under this domain. For example, in our case, we have a VM group, like a VM dot subdomain. Then there will probably be storage, network, etc. So with domains and these kind of structures here, you can create your namespaces, your basically domain namespaces for particular objects that you want to have being part of this project. So we did the domain, and next we do want to create for our specific type, the VM group, we do want to create the structure. So we do create an API where the group is VM, the version is v1 alpha 1, everything will be related to the codeconnect.vmworld.com overall domain, and then we have a kind VM group. So that is what our controller is going to be for. Yes, create the resource and create a controller. So now you could actually go ahead and create more APIs. You could create group storage, group network, and give it different kinds, or on the same group, create a different, whatever, photo group, what have you. Everything can be within one project structure if you want, and Kubernetes will build out these types. Yes.
I just recommend the audience to really spend some time to read about API group versions, and because this is really part of the fundamental of Kubernetes.
Yes.
Right? So we are creating the version v1 alpha 1 because this is academic, but every time you start to create your own CRDs, you want to start with alpha, then beta, then you go to stable CRD.
Yeah, right. Versioning. Exactly. And so, Rafa, you put a link here to read more about these kind of different kinds and conventions that we are just skimming over here. Okay. Okay, so we created the API, so everything is there. Let's now open up what KubeBuilder has done for us. So let's see. So this is our folder now, my operator, and then we have an API folder, bin, where the binaries go in, config stuff, controllers, hack, some bunch of scripts or text, and then yeah, Dockerfile, makefile. So essentially, this project is already ready to go. So we could build our controller right away. Everything would compile, but it's just like basically base scaffolding. So it doesn't know anything about our VM group besides that there is a spec and there's a status that we want to have. And KubeBuilder gives you like a default here starting point where it enters like a foo string and then a JSON annotation for how to marshal this under the covers and serialize it to Kubernetes. So basically, yes, it builds out the core code base for this controller, but nothing else. And so this is now where you come in and you start building out your controller structure with the types and some annotations and the control logic, etc. So in order to simplify that and to stay within the time, what we have done is we basically built that controller out for you. And so we will go through the final code piece by piece. But again, the manual that Rafa wrote here has the step-by-step descriptions of how to go from 0 to this one to then the full code base by copying the stuff in the right place. So you can follow along, but we want to highlight some of the things that you should be aware of. And so that's where we're going to spend some time on now. Okay, so back to my code base, my quote code base, which is the final operator. So here we are again, and this is the fully built out VM group spec that we are going to use. And so the one that you just saw had this kind of foo string in here, and we have a little bit more. Okay, so let's just focus on the attributes or yeah, properties that we set here on this ghost struct. Ghost struct is basically like a grouping of properties on a specific object. We do want to have a CPU, obviously, which is an integer 32 we define. We want to have memory. We want to have a template, which then should be a string. And we want to have replicas. Again, that's integer, a number. And you notice that there's this JSON representation here because under the covers, custom resource definitions or custom resources are stored as JSON data in Kubernetes. And so we have to provide this information to the Go compiler or the JSON library basically to change these field names to these JSON representations when it sends it over to wire. What we can also do, and this is pretty neat, we can start to build some validation around our objects definitions here. So for example, and this is just like primitive validation that we do here. We say this field is required. It needs a minimum of 1 and a maximum of 4. I could have also made this 8, but for the purpose of this exercise, we said that the CPU must be specified and it must be between 1 and 4. So you can enforce constraints. You can also put defaults in there, etc. So the KubeBuilder markers, they are called markers. They are pretty rich and you can do a lot of them with them. And the beauty of this is you do want to use them because the Kubernetes API server will use this information to validate and reject this information. Like an object that comes in that does not fit that validation, because back in the days when we had the beginning of like TPRs or the early CRDs, we didn't really have validation, and so you could literally dump anything in Kubernetes, and it was really hard to do versioning and maintenance on these objects. So we have much more validation robustness here in the code base. And then besides the spec, we also want to have a status, which then reflects the observed state that our controller has on this object when it acts on it based on the specification. And so for the ease of exercise here, I just created some very basic fields where we have a face, and that is just a string where it can either be running, pending, or error. We want to show the current replicas and then the desired replicas and also a last message. And if we go back here in our terminal, that's also the stuff that we partially see here. We have a last message, we have CPU, memory, face, etc. So this information is then being used by Kubernetes to show kubectl output and etc. Speaking
so very
of
quick, when you the folks on the call build your operator, you need to put a lot of thinking on your object schema. and what you want to see on the spec and on the status. And that's where your business logic gonna be.
Right, good point. And there's sometimes confusion about spec and status, so what should go in where. So the general recommendation is that every be represented as a desired state of this object should be in spec, and everything should be like the status should be reconstructible from the spec. Meaning, if your controller crashes and you write before that you write something in status as like, oh, I need to track something about this object, but I don't want to write it in the spec. I want to write it in the status just so I can track and read it later. And your controller crashes and comes back up. Don't rely on the status. The status should not be your basically source of truth or used for persisting information that is used to reconcile an object. Status is purely for representing, I'm the controller, this is my view of the world right now, and that's what I'm going to write in status. And you can go much more fancy with status here. So there are status conditions and arrays and a lot of stuff. So there's a little bit of guidance on the Kubernetes webpage around status. We kept it simple here to represent like very primitive information to an operator, like administrator, Kubernetes platform operator, to understand what's going on. So you've seen the printer columns here, last message and all the stuff. So this doesn't come out of the air from Kubernetes. So you need to tell Kubernetes where this comes from. And so KubeBuilder, again, is going to help you by giving you this option of specifying print column markers here. And then you say the column name and then what type it is. And then you say, give it a JSON path, since everything is JSON, you can reference to say phase is being constructed based on .status.phase. So based on the object that you get, Kubernetes will look in .status.phase and will use that information to populate that column here. And you can also use spec, etc. And like this JSON path logic here for printer columns can be like very complex. Again, we kept it simple. And then the rest is mostly untouched. So mainly you will implement the status and the spec, and then like most likely these markers here for telling Kubernetes about validation and so on. By the way, we talk a lot about KubeBuilder. There's an amazing guide, like a book on KubeBuilder, online book, where they cover all these kind of topics in depth for building complex operators. Like what are these markers? What can you put in there? And what if I want to watch multiple objects, not just my own types, but I'm also interested in nodes and etc. So there's a lot of information here on the KubeBuilder book. And they also have a quick start guide where they run you through an example of I think they are creating cron jobs and based on times, etc. to kick off certain jobs. I think that's the quick start guide here. So this is a very useful resource as well. Okay, so we have our types, but okay, so we have the types, but we still don't have our controller logic that does something. Like purely on the types, on these definitions, there's no concrete action that's going to be taken. So in the path controllers VM group _ controller.go, again, this file is being created by KubeBuilder for you, so you don't have to bootstrap that. You will see a little bit of code that is already there. For example, here, there's a reconcile function, there's a setup with manager function, etc. Ignore these kind of functions here for a bit. I created those. I like the create status here and the other ones. The main need and the most important part is the reconcile function. And I'm going to expand this in a bit, but I want to make sure that everyone understands that this is where your logic lives, where your controller logic lives. This is basically the entry point, if you will, for the logic that you're going to write. Before we jump into that, that is basically the code, the logic that is written, but Kubernetes needs to have an understanding of your type. And so how do we go from defining our Go objects like status and VM groups, etc., to a custom resource definition that we can send to Kubernetes, that now Kubernetes understands this object and will accept these YAML files or object representations that we've seen earlier. And so KubeBuilder has a command, make install, where once you have defined all this, it will go through the code base, create a CRD and install that CRD in Kubernetes, so that now Kubernetes understands, oh, okay, I'm also now be responsible for an API called VM group. And
yeah, very quick, Mike. I think that was one of the major piece of knowledge that I got from this exercise with Mike. Basically, you can extend Kubernetes of your CRD without necessarily having a controller built. So you spend your time creating your spec and status and your type. Then you run make install, basically going to create a YAML file with the CRD, and you do a kubectl create. And now at that point, your Kubernetes cluster understand the CRD. You need to be a cluster admin to run that command. Not necessarily having a controller built yet. So
Right.
that distinction is very important, because you can do even in phases. First, you do spend some time doing the CRD and then tackling the controller after.
Right, that's a good point. So it's mostly about schema, which is the custom resource definition, which defines your API. And then it's about implementing the logic that acts on these objects, on these concrete types, in this case, the VM groups. And so here's the custom resource definition that KubeBuilder creates for us with the make generate or make install command. So they're all make targets. There's nothing that you have to manually create. It's really easy. Again, everything is in the guide that Rafael wrote. Just quickly go through here. This is like any other Kubernetes object definition. It has an API version, it has a kind, in this case, custom resource definition. And then it has the, like the short names are defined, the printer columns. So everything that Kubernetes needs to know about our object, so it can represent that in the API. Okay, we have already installed that. That's why we wanted to show you earlier how to deploy a VM group. So that's why we already have installed that, but it's literally just a make install command by KubeBuilder. Okay, so schema done, types done. Now let's go to the logic, to the meat. So we have this reconcile function. And when you basically create this with KubeBuilder, there's a bunch of lines of code, and then it says here, implement your logic here. So the rest of this would be all empty.
So let's very quick, just so to help folks to follow. The reconcile function is inside of a directory of controllers. So you have the main.go, which is your entry point of your controller. Then inside of that directory, remember that we're gonna have one controller per object. So this is the controller for the object VM group. That's all.
That's right. There's obviously also a main go, because if you're aware of like executable binaries, you have to have a main, like an entry point to your whole program that is in main. We'll come to that in a bit, because there's a bit of stuff that you might want to have optional to your controller. For example, in our case, we do want to ignore TLS certificate warnings by vCenter. So there's a flag that we added to the controller. If you boot it up and say -insecure, the controller will ignore TLS errors, for example. So these are the things that you would do in main, but we'll come to that in a bit. But quickly on the reconcile. The reconcile function, or the parameters basically that you have, is it accepts a request, a reconcile request, which is nothing but a name in the namespace of the object. So for example, for VG-1, for that one here, the request would contain VG-1 as a name, and the namespace, the one that you give if you do kubectl create something, be it default or VM operator or whatever. And then you basically kick off your logic. This is this reconcile function here is called for every object that gets into your code. If you have questions on like multi-threading or how can I parallelize this, like if I have a lot of objects, there's a lot of tuning that you can do under the covers for KubeBuilder to tell the controller runtime internally, hey, I want to spin up like 5 Go routines that, or like workers that work against all these objects that come in. By default, it's using just one Go routine, so it's all sequentially, and they will go one by one. The objects that can come in, but this is tunable. So the first stuff that you do some basics. You create a Go context. We're not going to go deep here on context, but it's mainly used for propagating information through the system. Like I want to cancel this RPC, and you can use context for that. That is not strictly required. The next one is logging. So we get a log off already from the controller runtime. And in this case, we are basically enriching that for our reconcile loop with some key value data, which is the VM group, and then give it a namespace name. So that is then when these log lines print out, you will see a log line saying the timestamp and then the VM group and then the name of the VM group with the namespace that right now we are operating on, the controller is operating on. So the problem, quote, quote, is you only get a name and a namespace. You don't get the full spec. You don't get like CPU1, etc. this is what you have to get from the Kubernetes client. What does it mean? Well, in order to get the full representation of this object, instead of just a name in a namespace, we need to retrieve that object from Kubernetes. Now, it would be wasteful to always call out into the Kubernetes API server and say, give me this object, give me this object, give me this object. So under the covers, it will use a cache. There's an interesting implementation here where under the covers, there's a cache being fed by Kubernetes with these kind of change events. And so you will get against the cache. This is configurable. You can also go against the API server, but by default, the reads will go against the cache. The write will go directly to Kubernetes. Okay, so now we are getting our object into this type, this concrete VM group type. And there's a bit of log statements here. And then there's a bunch of checks which will come back in a bit because this is handling deletion logic, but we want to start with creation logic first. But the logic here is always if you want to exit early from this whole loop, from this function. That's why we always check first, is this object marked for deletion? We'll come back to this code base in a bit, but start with the actual, like a create or an update event here. So this is the code that happens, that starts investigating, okay, given this desired state of a VM group one with spec and desired like a CPU, etc., is there already a folder existing? Because we cannot assume that nothing is in vCenter yet. We have to assume that there might already be a folder created, which we might have done earlier from a previous job, but then we crashed. And so you always have to anticipate these kind of facts that after every line of code here, you can crash. So the logic should be written in a way, not that you think about, oh, is this a create or is this an update? Think about what is the current state and what is the desired state, and try to gather information about the current state. So what we do, the first thing that we do is we try to get the VM group. Okay, let's just quickly peek into that function. So there's a bunch of helpers that I wrote, which are in the vsphere.go file. So this is not in the controller. I just broke this out so it's easier to read. The get VM group is basically a code to retrieve an object from vCenter. In this particular case, a folder. So what we are using here is a library. Where is it? It's the library called govimami, which is the Go vSphere client API, if you will. Or vSphere client to talk to vCenter, to the vCenter APIs. That's govimami. And that's what we are using here. And in this case, we are constructing a finder. Think of a finder like your mouse pointer going through vCenter, and it's trying to find a folder with a specific path. We construct the path based on the path that we know, like VM-operator, and then we just append the name of the VM group. So that's how we construct the path. We try to find this folder. If we can't find it, because it doesn't exist, we return it. If there's another error, for example, vCenter is down, we can't reach vCenter, we also return from this function with an error. So if we return from this function with an error, there could be two cases. First, let me go back, sorry. Here's the entry point again. If we come back with an error from this code base, it could be, again, that this object does not exist. So we need to create it. So that's a positive error, if you will. Or it's like more like a permanent error, like vCenter is down or permissions are not sufficient, etc. Something is horribly wrong. And we also want to cover this. But this means there's two cases. The first positive case is we need to create something, so we proceed with the logic. The other one where vCenter cannot be reached or whatever, we want to make a decision. And in this case, the decision that we make is to return from that logic, from that whole reconcile loop here, and put an error status, error condition. An error basically means we will never see this object again. We are saying, I can't resolve this. Let someone figure that out, like an admin, and give it some message and an error description, like the one that you've seen earlier when we had this issue with the deployment, where it said the template couldn't be found or something like that. Okay. So this is the logic that you always have to do after every step. Check if there's an API error or whatever error against vCenter. And these are the kind of the side effects or this kind of non-determinism that we have. Once we go outside of Kubernetes, we have to think about all these corner cases, things that can go wrong, and then we have to make a decision. And in this case, we make a permanent error decision for not being able to retrieve the folder. If it's not found, that's a different error, and then we continue. Okay, so if we don't find it, well, the next action is to create it. So if it doesn't exist, create it. Well, there's another vSphere command here, which is create folder, create VM group. Not going to dive into the code base. You will see that here in vSphere Go, but basically it's doing the same. It's trying to create a folder within our VM operator folder. And then if it has an error being returned, then we throw back that error and say, oh, we can't create a folder. There's a permanent error, and we error out. If that succeeds, now we have a folder. The next thing that we need to do is populate this folder with the number of replicas. But before we can do that, so imagine we crashed right away here. Like we did that, we created a folder, and then we crashed. Next time we come up, we find this folder. Now we have to make sure, oh, are there actually already VMs in that folder? Because we don't know where we left off from the last time. So we always have to go through and investigate and gather more information from the system. So instead of right away creating virtual machines in there, we don't assume that there are virtual machines there. We try to get the replicas. Assuming in this case, likely there won't be any replicas, but who knows, right? You have to just be very defensive. So here we try to get the replicas. We store them in a variable VMs. If, again, an error like a vCenter API error occurs or whatever, we throw it back with an error condition. Otherwise, we continue. And now it's time to create the replicas. If there are no replicas existing, like 0, then we do create the number of replicas as specified in the spec. So let's quickly highlight this here. There is a desired number that we retrieved earlier from the spec. So this is all in the spec in there. So let me show that here. So vg.spec.replicas is where we capture the desired number of replicas that we want. And then we just have a for loop which goes over like 0 to the number of desired. And then we spin up a bunch of Go routines. In order to not overwhelm vCenter, what we do is we create a limiter. A limiter is something that you can or should use to constrain the number of calls against vCenter. This is just a safety net because you mentioned someone wants to create 100 replicas. The last thing that you want to do is go out and create 100 replicas or virtual machines right away. You want to limit the concurrency level a little bit. And so there's a tiny limiter that we implemented here based on the default concurrency level, which is 3, basically saying you are allowed to perform 3 API calls, in that case, create calls against vCenter. And then all the other ones would just block and wait until one routine finishes and then the other one comes out. So we're using Go routines here for kind of this parallelism, but we constrain the parallelism a little bit to not overwhelm vCenter. And this is like tunable. Okay, so if there's an error coming out of one of these operations, then we want to throw back that error, obviously. And in this case, for example, let's assume we created 2 VMs and the last one couldn't be created. Then we don't want to error completely out, but we want to say pending. We do want to retry the next time. And this is, here's a beautiful implementation of the Go, like the Kubernetes code base. We can basically say return an error. And if that error is returned from that function here or a requeue, it basically means give me that object again in a specific time. So the behavior of QBuilder is if you return with a requeue request, meaning I did something, but I want to see that object again in 5 minutes, then you will get, again, the same object by QBuilder in the next loop, reconcile loop. Or if you return with an error, then you will also see that object again. So this is just like a behavior of the function of the library here, which is pretty neat. For example, if things go wrong, but you might want to retry, then you just return and then you will see that object again. But in our case, let's assume everything went well. We went through this here. Then the last thing that we have to do, like the VMs are running, everything is good. The last thing that we have to do is put a status inside the system and saying they are all in running state, these virtual machines. So now we are also attaching a status information to our object. So spec we have, status we are going to add to this object and say we are done, we are good. We have a success message, which just says successfully reconciled VM group. Here, that's a constant string. And then we are done and we can return successfully from this loop and iteration, and then we are good. In this case, we won't see that object again because we said we are good. I cover another part in a bit. But this is, in a nutshell, the logic for creating, or if you will, updating a virtual machine. So we just covered the creation here. Rafa, how are we doing in time?
We're 25 minutes still. And
okay.
One thing that I would like, if you can have a chance to show folks how the trust between the controller to the vCenter with the environmental variables, how government is gonna know which vCenter to connect.
Oh yes, okay. So we decided as part of this setup here, when the controller boots up and the whole logic, like even before the reconciled stuff, like the bootstrapping of the controller itself, there's a bunch of stuff that happens. And in Go, the file for that is main Go, which is the entry point of the program. And then in main Go, you can create some flags. For example, there are certain flags which are already there from KubeBuilder, which is metrics and leader election. So KubeBuilder already also gives you the chance to do leader election, which is pretty nice if you have multiple controllers for failure tolerance. But we also added the insecure flag that's here. That's what I mentioned earlier. But now the question is, how do we actually know where to connect to? And there's different patterns. What we are doing here is we are feeding the system with environment variables. That means before I created my controller here, let me stop this guy here. I did export on environment variables so that when I run this locally, these variables will be picked up. And so it knows where the VC host is, the user, and the password. Now, the beauty of this is we can actually, when we are running inside a Kubernetes cluster, obviously we don't want to have someone type in these commands or log into the deployment. You can create a secret, a Kubernetes secret, with the same properties. And this is actually in the manual, right, Rafa? Where you create the secret, and then the secret can be injected either as a plain file into the controller. So you would open a file here and read it, or you can also inject secret parameters as part of environment variables. So our code doesn't change if it's deployed inside Kubernetes. The only difference is that if you deploy it into Kubernetes, you have to create a secret before that, which is analogous to the export command that I'm running locally to the controller. Okay. Good, thanks, Rafa. Good point. Okay, so I want to leave some time at the end of the session. So I want to cover a little bit of the other logic that we also have, because we talked a lot about creating objects. Now the question might be, okay, since we don't know, is that a create or an update or a delete? Well, strictly speaking, well, we can understand what it is, but you should not assume that this is kind of some of the concepts that you're dealing with, because the logic that you write should always just be, you get an information and then you look at the current state and the desired state, and then you perform an action, and not, oh, that's an updated event. There must be something there. So this is not how you should write your logic. Your logic should literally be very defensive and then check all these things before. Now, let's assume we created our VG object. So we have, let's go back here. Our VM group is running. Let's now simulate a change of the object. And what is also nice with KubeBuilder, it gives you this capability of using kubectl scale. So I can do k-nvm operator scale, and then it will say my VG group. Where is it? No, VG. What's the name of the VG? VG-1, right? If that's the.
That's right.
Yeah, giving like 8. Shall we do 8 VMs for the VG?
Oh, why not?
Yeah. Okay. So we can actually just use the scale command in kubectl to scale up or down our VM group. And let's do this. And what I'm going to try to show here is that this is now a change to an existing object. And so how does our controller do that? So, okay, so Kubernetes said it scaled. Well, technically it did not. Eventual consistency, you remember, it just instructed the system that there's a change in the spec now where it says desired 8, current is 3. So let's go back to our controller. Yes, and nothing is happening because the controller is not running. I stopped it. So let's run it. And that's what Rafa also mentioned earlier, is you can manipulate all these objects without a running controller. Obviously nothing will happen. Now the controller will boot up and it will see a change, or basically it will get the full state of the system, which says, oh, there's 8 VMs that I need to create. And then here's it throwing, oh, it already existed. It has a name collision. So it tries to create other VMs. So it goes ahead, creates a bunch of virtual machines. We'll do that. And then eventually, once it's done, so you can see they are coming in 1, 2, or they're already 8. Well, let's just wait. Let's just wait it out. Maybe we are in luck and we have, okay, it's done. I was hoping that we got into a state where the system is actually, where we just had 7 or so, because there's the case which I run into, for example, you run out of space. There's no space left on the on the VM data store, or a quota is hit or whatever. So when the controller cannot make progress, the behavior there in the system is that you can either throw back an error in your reconcile logic. So let's go back in here. If we throw back an error here from this reconcile function, then you will see this object again. If you throw back a requeue request, like no error, but you say, give me this object again in 5 minutes because I just want to make sure that really everything went well, Kubernetes will also give you back that object. But there's also another option which you can set on the controller, which is the resync period. And I think it's, where is it? Let me see, sync period. Here, sync period. And that says every, whatever, 5-10 minutes, you will see all the objects again. And this is quite useful because I had the case where I powered off a virtual machine or it couldn't be powered on. So from the controller, it created all these objects. So this was fine. So it did 8 in this case. But imagine 1 or 2 are powered off. Well, then strictly speaking, they are not really running, right? They are not really reconciled. But we don't really know because we did our job of creating 8 of these virtual machines. Now, what happens if you have this sync period, you can tell Kubernetes, even if I close the last loop successfully and I said, oh, well, I'm done, I'm fine, I don't want to see this object again, Kubernetes will give you the whole state of all these VGs again after like 10 minutes or so. So you get a chance to perform a reconciliation again. And this is especially important because some of these tasks that we are performing here inside that reconcile function or loop, well, it's not a loop, it's a function, they could take time. Cloning a VM could take very long. In this case, I'm just cloning a plain like small image. So that's quick. That's why everything here in our code is kind of synchronously. But for larger VMs or for operations that take time, you want to do them asynchronously. You just want to kick them off and then return as early as possible from this reconcile function. Because as long as you're inside that function, all the other objects will queue up, if any, and if you don't have like these multi-workers enabled in the queue builder. So that's why you want to keep the whole logic pretty short inside that reconcile function and then later come back. And by coming back, what I mean there is either a requeue with a request that we've seen earlier here, somewhere a requeue request, where you can say, give me that object again in 5 minutes, or you say sync period, which basically is a global setting for your controller where every 10 minutes or so it will do, will give you all the objects again, and then you can do some comparison. Let's see that actually in action. Rafa, comment?
Yeah, 15 minutes to go. I suggest you to go over the finalizer to deletion.
Yes, exactly, exactly. Let's cover the delete part now, which is pretty interesting because there's a lot of problems and corner cases waiting for you once you go out of Kubernetes, in this case, to vCenter. So how can you actually detect whether an object has been deleted? Because you don't get a deleted event here, you just get an object, right? So the first thing, that's why it's pretty early here in the code base, you check for a deletion timestamp being set. And there's a small helper here on the metadata of this object. So every object that in Kubernetes is deleted, kubectl delete something, will get a deletion timestamp. And if that is not 0, it basically means this object is marked for deletion and the system gives you some time to delete and clean up. And so we're checking this here. If it's not 0, meaning is it marked for deletion, we enter some logic here and we say VM group is marked for deletion. And then we check if there's a finalizer in that list. What is a finalizer? So you will only get this object or this information once. Like if something is marked for deletion, you will get an information here, data and deletion timestamp something. Now, if something fails along the lines with like your clean up logic, etc., Kubernetes won't give you that object again. There's no like say, hey, I want to have it again because it's technically gone. There's only one way to delay that deletion or garbage collection in Kubernetes, which is by using a finalizer. And a finalizer is nothing but an entry on that object in a list where you can just put yourself in and say, hey, before Kubernetes, you do delete that object like completely from the database. You tell me, you ask me, you wait for my confirmation that this is done. And so the first thing on an object that you get, and it's not deleted, you do want to make sure that you add yourself to this list of finalizers. That's the first thing that whenever the object is not marked for deletion, you do want to make sure that you're in that list because you want to have like a hold on this object. Now, in this case, we check, does this finalizer name exist here? If so, if our finalizer is present, we need to clean up. And so there's a function here, delete external resources, which will basically go into vCenter, power off the VMs, delete the folder, clean up everything. If we fail along the lines here, we return with an error. But because our finalizer is still in that list, Kubernetes won't be able to delete that object from the API server. It will literally be pending, and a kubectl delete would just be stuck there at that place. So Kubernetes is not deleting that unless there's no finalizers left in that list, which in our case, we are still in. Okay, so then you get another chance. You do your work. Let's assume everything went well. You deleted everything. Well, let's actually do this here just for the purpose of.
Yeah. I don't know if folks ever had this problem when you delete an object in Kubernetes and the object never goes away. Yeah.
Yeah.
So
yeah, yeah.
this
actually,
is why.
Let's simulate this. So I stopped my controller here. Let's delete it. Nothing happens, right? And so let's run the controller now, locally again. So technically, if there's no finalizer in the list, Kubernetes would have gone and deleted it, and you would never have seen that delete object, basically. And you would have inconsistent state between vCenter showing objects and Kubernetes has already forgotten it. In this case, because the finalizer was in the list, you see that the controller kicked in. Let's quickly jump over here. And again, parallelism, like 3 concurrent calls, it will start cleaning up, deleting power off, deleting the object, and then eventually deleting the virtual machine. And now it's done. Yeah, now it's gone. We're good, deleted folder. The resources are all gone, and this command unblocked here, right? We're good. And so this is the logic to deal with these kind of consistency or inconsistency issues when you're outside of Kubernetes. Resync for every 10 minutes, give me all the objects just to make sure that they're all powered on or whatever you want to do, or the load balancer, for example, you want to make sure that the IPs are correct, whatever. And for deleting, you put yourself in that list. If you're still in that list, Kubernetes won't delete, you do your work, and then you just remove that string. It's literally just a string in that object. And if there are no finalizers in the list anymore, then Kubernetes goes ahead and garbage collects, and that's it. And then you will never see that object again, and we're good. All right, there was a lot of stuff that we covered here, and we could just scratch the surface, but I wanted to make sure that we cover the essence, the most important parts of like this reconcile logic. The rest is just boilerplate, like creating a VM group, getting the folder powered on, like all these checks, you can read the code. There's nothing fancy in there. I just want to make sure conceptually that we understand this loop. So before we close this off for questions, let's just skim through, like the whole README is amazing. It's really good work, Rafa. And you can follow along and just play with it. So we did that here. There's also a setting for how to deploy this now to a Kubernetes environment. So Rafa has commands to deploy that controller to the cluster. So this is what we skipped for now. I want to discuss some points that we could not cover, which are here, advanced topics, just briefly. So first of all, the code might not be in the best state, right? This is purely educational exercise. There might be code that is repetitive, so feel free to shoot some PRs and improve the code base there. We also don't touch on unit integration and end-to-end testing for the code base. Obviously, this is something that you do want to do. We skipped over this. KubeBuilder gives you some scaffolding also around integration testing, which is pretty neat. Yeah, the error handling could have been better. In some errors, we just don't retry. We just throw it back to the operator, like to a human to figure that out. That could have been better. We don't support multi-cluster, multi-VC topologies here. We just have like one controller is responsible for one VC. So you could obviously scale it out, but multi-VC would be a nice addition. We do generate a lot of names in the system, and we don't really check for the length of the names. And so Kubernetes has a certain limit on naming. So you have to make sure that if you have a long namespace name and a long replica set name or VM group name, that could be truncated. And so you probably won't be able to find that object name later because it's not what you're expected it to be. We didn't cover RBAC, like rows-based access control. KubeBuilder gives you macros. Actually, the code is quite here, where you can say, for this group, RBAC create some files. And then here in config, you will see the RBAC files, which it creates all out. It's pretty nice. So no fiddling with manual stuff, but we didn't go fancy there, just basic stuff. The whole stuff on caching, local indexing, async handling, we didn't really implement that here in the code base. Again, you should keep the reconcile loop short as possible from a time perspective. Don't block too long there. And use some smart caching and don't always reach out to vCenter and say, hey, what's your folder name or so. So we didn't implement a lot of caching there. That's this one. Yeah, there's a bunch of other stuff and things that if you want to go fancy with building operators, you can also do expectations. So if you don't see, if you do a change in the system, you're going to expect that this is going to happen. So you can express some expectations in your control logic, and unless they are not fulfilled, you're waiting and you're always returning earlier. That is expectations. There's a link here. Requeuing is pretty primitive for now. We just throw it back and we have a default requeue time. That could be much smarter. Isa, raised hand. Of course, Isa, go ahead. Is there maybe a question in the chat? Isa, no question in the chat. Isa, do you want to post your question in the chat? Because I think we don't have audio, right? Just post it in the chat. I'll watch the chat here. What else? Yeah, vCenter task management and tracking. So all these operations against vCenter give you back a task, which you can then track for progress. Because even in vCenter, there's a lot of things that go like asynchronously. We are waiting for these tasks to finish here. So we are basically blocking. Again, this is not best practice. vCenter session management. Yeah, we're just relying on basic Govimami session management. This could actually be much smarter, like checking whether the session is still alive, so you don't run into issues where you get an unauthenticated error from the vCenter API and then we error out, and lots of stuff more. So
yeah, you could, like, for example, you could create a root object called vCenter, and then you put everything there as a CRD. But you know, that's something that, and then of course supports multiple connections to multiple vCenters.
Yeah, and there's a bunch of techniques and tricks to perform on these controllers. So a controller can watch its own resources, it can watch child resources, but it can also watch arbitrary resources in Kubernetes. So you can gather all this information from Kubernetes if you want. So this is in those advanced topics, they're all here in the quick start. Even though it's called quick start, it's actually pretty deep guide. And shout out and kudos to the KubeBuilder team, especially Soliros, the Cluster API team, Andy Goldstein, Tim Sinclair. Like I learned a lot from these people along the way of building operators. Again, it's not an easy task, and you can even tell from this code base here, which is like doing basic CRUD operations against vCenter. There's a lot of stuff involved, and again, we didn't cover the advanced topics, which are the topics that you want to make sure you get them right in for production environments. So that's why the reference in the beginning for Cluster API, if you want to learn more about how to do it right, basically, quote, right. Cool. That was it. Well, that was a fire hose, I think. And
yeah, if you guys want to take your time to go over the README, I myself, I had some troubleshooting here and there. There's a whole section in the end of the page, like common errors or like you might encounter, you know, getting Go modules. And even if you're not familiar with Go, I would say that this is a great start to learn Go.
Yes, the guide really gives you, even if you're not a developer, not a Go expert, yes, we'll share the recording. Thanks, Kripa. You can literally go from 0 to operator with this manual there. Cool. We'll hang out a bit for questions. Thanks everyone for joining. It was a pleasure to be on the show, Kripa. Thanks also for setting this up, Kripa. Was very well prepared. That's cool. Thanks, Mikhail. Yeah, I'll wait here and see if there's questions. Thank you for the presentation. Thanks, Laurent. Simone, nice. And thanks, Rafa, by the way, my buddy.
Well, thank you. Yeah, one thing that so in this past 2 weeks working with Mike and documenting and learning all the I have some contributions with Valero, but I found some gaps in the knowledge that I had when it comes to operator, and the CRD for me was very enlightening. The whole validation part, for example, it's a new feature of Kubernetes as of 1.16.
It graduated
right.
in 1.16.
Yeah, graduated 1.16. So you have all this, and you don't have to compile. You don't have to have to run make install or make generate from KubeBuilder, but it's a given. You don't have to be a software developer to come up with your own CRDs. There's a question from Mohan. How schema changes when designed for a stateful versus stateless app? You wanna take that?
Where's the question?
How schema changes when designing for a stateful versus stateless application? I can only guess he's talking about most CRDs that depends on a state. That's my interpretation of the question. Schema changes on the CRD, stateful versus stateless.
It's in the Q&A. Oh, I'm looking at the chat. Sorry, wrong window. How schema changes when designing for stateful versus stateless application. So I'm gonna, hopefully I'm getting the question right here. So maybe this goes back to the stateless, stateful approach that I mentioned earlier. So from the controller perspective, it's supposed to be stateless in terms of like the status in Kubernetes and etcd in terms of the data description of this object, right? So that's why these controllers are kind of stateless and just have in-memory state. Now, if the controller or operator is responsible for owning or operating on a stateful application, and maybe that is part of the question here, where you have the canonical example is the guestbook application where they spin up a front end and a database there, and you want to make sure that maybe the database is ready before the front end is there, etc. So there are like the patterns are basically the same. So the schema, the specs, you would probably have different specs, one for the database, one for the front end, and then your operator can take action on all of them, or you want to have two operators, one for the backend, one for the front end, and then again they work basically in tandem without actually knowing about. And there is, and that's I can share that there is Solly Ross did a KubeBuilder workshop with its stateful application with I think 3-tier or at least 2-tier application. I can share that in the chat here, so it's captured, where he describes building operators for stateful applications or a controller for stateful application. Again, but the patterns are the same. The spec, the status, everything is the same. It's just a matter of the logic that you then implement. And stateful actually is much harder, Mohan, than doing stateless because there's so many things that can go wrong. And speaking of which, there is one. Why do I have it here? This is Solly's. Mohan, you want to check this one out? This is his zero to operator talk, and I think that's using the web page database example. Then he has a list of all these workshops as well here that you can follow up. And then there's a, oh, by the way, shout out to this book, Programming Kubernetes. So if you really want to go deep and learn this kind of stuff, just buy this book. You can blindly buy it. It's an amazing book by Stefan and Michael Hausenblas. And Stateful, this is the talk that I want to share. Well, there's a lot of talks here that you can watch, but there's one particular one. It's not in here. Sorry, I'm gonna find it out. It's from the Elastic team. They built an Elasticsearch operator, and that's really advanced talk. Rafa, you want to answer live? Or oh, that's because I answered live, right? YouTube.
Yes.
KubeCon, let's see if I can find it. Elastic operator, the hard parts. I think the hard parts or something like that. Yeah, this one here. I'm gonna post it in the chat. This talk is amazing, and it actually makes you believing that writing operators is really, really too hard. And that's why, if you jump the gun too quickly on operators, you set yourself up for trouble. So it's a nice learning exercise, but always like think about the tools and the stuff that you want to achieve. Maybe there's other ways. Cool. Any other questions? Thanks. Oh yeah, thanks, Mohan. Hopefully this was helpful.
Right. If you guys have any questions deploying the operator, reach out to us on our GitHub handlers is out there.
Yeah, where's the page again? Here. Yeah, here's the.
Yeah, just pay attention with, because this is academic code. There is some vCenter particularities. You need to have only a single data center, for example, managed by the vCenter. Have to create the VM operator folder. It's all in there, but reach out to us if you have any questions and we can take offline.
Cool, amazing. We're on time. Yes, Simone was asking slides and links will be shared. Kripa, pretty sure they will be shared later.
Yes.
And everything is also here. Oh, sorry.
Nothing. I will definitely share it. Thank you guys so much. That was a fantastic session.
Thank you. Thank you, Kripa, again. And thanks for everyone tuning in. Thank you very much. Bye-bye.
Thank you.
Bye.